Hi, so I'm Sujit Manigandan, and in this video, I will be showing a demonstration of my uh, agentic AI model that I built for a IBM Hackathon. So this project I did it with my friend Santosh Dayakar. So the idea is actually to help the visually impaired and blind people to access various functions that we use in our everyday life with ease. But unfortunately, because of their impairment, it's difficult for them to visually see and access some of the services. So in order to solve their issue, we built a model. So what it does is like we made use of the Azure speech to text model. So it's been deployed in Azure AI Foundry. So you could see here, so this is my Azure AI Foundry, and you could see the Whisper model that is currently deployed. So I use this model for the text to speech to text. So there's a web server running. So uh, as soon as the user opens the site, so the user will be able to start speaking. So once the user starts speaking, the Azure Whisper model will actually transcribe the speech to text, and that transcribed text is actually taken as the input to the agentic AI model that's deployed on Watson X Orchestrate. So the base LLM is Granite. So this is going to be the project model. So this is the saved agent that I have. So the model that you can see is Granite, and it's running on the LangGraph framework with the React architecture. So these are some of the prompting instructions that I use to make the model execute what it needs to execute properly. So apart from that, I do have like a few other things to show now. So these you could see the Google search and the Wikipedia and web crawler tools. So these are some of the built-in tools that the agentic AI in IBM Watson provides. Whereas I also have some other custom-made tools that makes the users to do more functions. So these are some of the tools that I've used. I make use of the Google Maps API, and then the Google Distances API, and then the Google Maps Directions API. So to show the demonstration of the tool, so wait. So I'll be deploying the Python engine now in order to show the demonstration. So now it's being deployed, it's in progress. So you could see how I do this. So I do have some of the code over here. So I do have the input JSON file that I've mentioned over here. So I do have the Google Maps code. So I give the tool description. So it's this description that the LLM makes use. I mean, the agent will make use of this description to decide whether to call the API, call this tool or not. So on giving the mode of driving, the origin and the destination will be able to give us the directions and then the routes. So I'll just show you a demonstration of how this agent will make use of this Google Maps and the routes API that I have configured. So let's just say I live in Montreal and I currently study in Concordia. So Concordia has like two different campus. One is known as the SGW campus and the other one is the Loyola campus. So I'm just going to ask the route from one campus to another. So I'm giving the query, asking it to give the directions. So you could see that it gives me the directions, but you may feel that this is just a standard model that is working, but that's not the case, because if I just click on this, how did I get this answer here? So you could see the steps that were involved by this agent in generating the step. So the first step of the agent is to make use of the tool Google Maps Directions API that I just provided over here. So this is the API that I provided and configured. So I have the code over here, and you could see the input JSON file. So as you could see, the input given was the origin, Concordia University SGW campus, and then the destination was Concordia University's Loyola campus. So the agent making use of LangGraph is able to decide and turn the textual query that I give, and it decides on which tool to call so that it gets the answer. So this is the output that is returned by the API. You could see that. You could see the entire trace. And then as a second step, the output is turned into a proper string of words using the Granite model that is running. So this is how the agent basically works. So I will demonstrate another one of my ones. So this is one of my functions. So these are the three functions to access a memory store. So every agent, in order to serve the user better, it needs access to a memory store so that it can store more important details of the users and then access it back to serve the user better. So for that purpose, what I do is like I make use of the document DB database in AWS. So that is where I have you could see the AI agent document DB memory database. So every data gets stored in the database. So what these functions do, so if I click on the get database function, so get from memory store function, so this is just a uh, request call to the URL. So this URL, what it does is that it sends a URL to, it runs a Lambda function that I have on the AWS Lambda server. So this is the function that I have on the AWS Lambda server to access my MongoDB database. So you can see the code over here. So it has three functions. One will be adding something to the memory. If the agent wants to add something to the memory, it will call this particular function so that this will execute and add the key value pair to the memory, and then get memory. So the agent uses this to get information from the memory and search for relevant information that I ask. And then I have something called the delete memory. So if I ask the agent to delete something, then it will delete the thing from the memory. So I'll show you the demonstration of this one now as well. So let's just say, let me just ask, what is my emergency contact? So let me just ask, what is my emergency contact? Your emergency contact is Santosh Dayaka. So it has written this from the memory. So I'll show you the proof. How did I get this answer? So on clicking on the first step, I have this. So you see the tool that was called as get memory store tool with no input, because in order to access something from the memory, we don't need to provide anything. So get memory store. So you have this thing. So it just runs the Lambda function. So that Lambda function, what it does, it uses the get memory store and returns all the documents in the MongoDB database as a key value pair. So it's that those key value pairs you can see here. So as I open this, you could see the key value pairs that were provided. I have the emergency contact, and then I have various other values. I even have my name stored, and I have like some other values, my favorite food and my favorite color and stuff like that. So from the memory that was accessed, this IBM's LLM will know which key am I specifically asking for. So it will just give me the value of the answer. So I get this answer as Santosh Dayakar. Another one function is the Gmail API again. So Gmail API. So this is again a post request to the function that is running on Lambda. So this is just the input that needs to be given to the Gmail API. It needs the two value, the title, I mean, there's a subject and then the message. So yeah, I have the code for the email API. So I have the credentials stored in the JSON file. So this will just send the email with the credentials and then the message body and the two function from my own Gmail. This is just my personal Gmail. So I'll just try that. So just for demonstration, now I'll just open my mail. I'll just go to the sent section. So all right, so I just have these mails over here now. So let me just say something. So send an email to my emergency contact. So I'll just give some subject. Congratulating him on the completion of the IBM hackathon. So I've just sent. So you could see that the model is able to detect and it just creates proper input. So you could see what happened. So it just made a message saying that congratulations on the completion of the IBM hackathon. The subject it just created on its own. So the ID was Santosh Dayakar 2002 at gmail.com. Even though I do not specifically mention the email over here, I just told the model asking it to send it to my emergency contact. It was able to retrieve it from the memory that my emergency contact was Santosh Dayakar. And it's also able to make use of the Gmail API, which is the tool that I have given here. So to send him a successful email, and I've got the output saying that the email was sent successfully. So now let me go to the send section. I'll just refresh this one. So now you could see the new one that was sent to Santosh Dayakas. Congratulations on the completion of the IBM hackathon. So that was a success. So again, as I said, we made this project so that it could be helpful for the visually impaired and the blind people to use several of these functions. So what we have done here in this project is just a very minimal amount of functions. It's just three functions that we have. One is the memory store, the email Gmail API that is used to send mails, and then the Google Maps, the directions, and the routes API. So this functionality can be expanded further to like accommodate numerous number of services that will make the lives of these people much better. So it will be very easy for them to access most of these services. So now I will give you a demonstration of how the speech to text and the text to speech model part works. So it's just going to make use of this agent API, but it's just that the speech to text model will help the users to just access the agent only through speech instead of the chat section that I used here. So instead of giving the text or information, you can just directly speak to the agent so that the Azure Whisper model will provide the transcriptions to the agent, and then the result is again uh, turned to speech and played as audio back to the user. So now I just have my backend server running and then the React app running. So if I open the React app and if I am able to just speak, I will be able to process the transcription and get the result back as a speech. What is my emergency contact? So you could see that the file has been received now. The transcription result is provided from the Whisper Azure API model. So now this transcription will go to the agentic AI that is present in IBM Watson X, and I will get the result back. So you could see the response. Your emergency contact is Santosh Dayakar. I've got the response that is accessed from the document DB memory. And now the text to speech API will work to speak back again to me the answer.
Your emergency contact is Santosh Dayakar 2012 mail com.
So that's just a complete demonstration of the project. And as I said before, this project has a very great future scope. So it can be extended further and further with more and more functions integrated in it to help the users serve better. Thank you.